Hi GOR, this is Unit 3, Lesson 5, and we're going to continue to talk about proofs today. Hopefully you're not finding the proofs too hard. Remember, you have statements on the left, reasons on the right. You always start with the given, and the proof is done when you prove what they asked you to prove. So we're just going to continue with the proofs. The difference is today they won't be numbered, so you won't know how many steps there are. And I'm also going to ask another question at the end, is to describe the rigid motion that would map one triangle onto the other. Remember, in order for triangles to be congruent, there has to be a rigid motion that maps one onto the other. So I have statements on the left, reasons on the right. Start off with step 1, which is my given. And I'm going to mark everything that's in my given. So angle LNM is congruent to angle LNO, and MN is congruent to ON. That all is my given. And you want to mark your diagram because you need to know when you're done with the proof. When you have one of those 5 ways, you're done. So LNM, notice the N is in the middle, and LNO. So these two angles right here are congruent. And MN, which is a side, is congruent to ON. Now that's all the given. There's no keywords like midpoint or angle bisector or perpendicular or anything like that. So remember, there's always 2 things that we need to look for in a proof that's not going to be in the given, and that's if they share a side or if they have vertical angles. So look at this picture right there. What do they have? Hopefully you can see that they share that side LN. And hopefully you remember how to write that step. You just write LN is congruent to LN. Everything is congruent to itself. Try and remember the name of that property. It's reflexive property. At this point, my triangles, I have enough. If you see, I have 2 sides in one angle and the angles between the 2 sides. So my last step is what they wanted me to prove. Triangle LMN is congruent to triangle LON, and the reason is side angle side. So the additional thing here is they want me to say what rigid motion would map one triangle onto the other. Was it a rotation? Was it a reflection? Was it a translation? What was it? All right, and notice the letters can give us a little hint. Like L maps to L, that's the first letter. O maps to M, that's the second letter. And N maps to N. So the L is staying, the N is staying, and the O is mapping to the M right there. I did a reflection over the line LN, and I can write it like this. If you want to write out the word reflection, you can certainly write out the word reflection. But hopefully you can see if I was to reflect the triangle on the left over that line, it would land on top of that other triangle. All right, next one, I have a few more interesting things going on because I have an angle bisector and I have perpendicular lines. So those will allow me to write a few steps. Again, the statements on the left, reasons on the right. Statement 1 is just going to be my given. Perpendicular lines, hopefully you remember perpendicular lines form right angles. So my next step is going to say which angles are right angles. I will put them on my diagram and I will just number them angle 1 and angle 2. So BD, oops, sorry about that, guys. BD is perpendicular to AC. So this line right here is perpendicular. So that means my right angles are right down here at angle 1 and angle 2. So perpendicular lines form right angles. I'm going to say they're right angles. Angle 1 and angle 2 are right angles. Now, how do I know they're right angles? Because the lines are perpendicular. Perpendicular lines form right angles, but I just write definition perpendicular lines. If they're both right angles, that means they both equal 90, which means they have to equal each other. So I'm going to say angle 1 is congruent to angle 2. All right angles are congruent. We've been doing these 2 steps since day 1 of proofs. All right. DB bisects angle ABC. If I'm bisecting the angle, I'm bisecting angle ABC up here. That means I'm cutting ABC in half. So I'm going to call this angle 3 on the left and angle 4 on the right. An angle bisector cuts an angle in half, and the result is I have congruent angles. So angle 3 is congruent to angle 4. Definition, angle bisector. And that's my given. I did the perpendicular, I did the angle bisector, but I still don't have enough. So this is when you look at your picture and you say, do they have vertical angles or do they share a side? And once again, just like the one up above, they share that side. So BD is congruent to BD. Remember, when something's congruent to itself, we call that the reflexive property. And now I can say that my triangles are congruent to each other. I've been marking my diagram so I can see why they're congruent. So triangle ABD is congruent to triangle CBD. And the reason is angle side angle. Again, they want me to describe the ridge of motion that would map triangle ABD, which is on the left, onto CBD, which is on the right. And hopefully you can see it's just like the one above. I'm just reflecting it over that line in the middle. So I'm doing a reflection over BD. All right. And hopefully you're seeing some of these same givens will give you the same statements that you can write. 3 is a little bit different. I have parallel lines. Normally when I have parallel lines, I results in alternate interior angles being congruent, so I'm going to look for that. AB is congruent to CD, that's in the given, and AB is parallel to CD. That's all my given, step 1. Now the fact that they're parallel, remember if I have 2 parallel lines and a transversal, that means these alternate interior angles are congruent. I have that same thing right here. I'm going to call that angle 1 and angle 2. Those alternate interior angles are congruent. So I put that as a statement. Angle 1 congruent to angle 2. Why? Alternate interior angles are congruent. And once again, they share that side. So that's a nice, easy step. Even if you're struggling with these proofs and you're not getting all the steps, you can certainly get some of the steps. They share a side. You say the side is equal to itself. BD is congruent to BD, reflexive property. And then my triangles are congruent. And you can see I have 2 sides and the angle between them. So triangle ABD is congruent to triangle CDB. And the reason is side angle side. Now this one is a different one for describe the rigid motion. I am not reflecting it, okay? I am actually rotating it. If I was to flip it over this line, that would not result in the sides matching up with each other. Now one way you sort of know that, look how B is the second letter and D is the second letter. That means B is mapping onto D and D is mapping onto B. So I am doing a rotation of 180 degrees. Okay, so this one is not a reflection. Hopefully you can see the difference, but we can talk about that tomorrow in class. How 1 and 2 were a reflection over the line, but choice 3 right here, proof 3, exercise 3, is not a rotation, is not a reflection, it's a rotation. Let's try 2 more on the, well, let's try 1 more in the back, and then I think I'll leave number 5 for in class tomorrow. We should have enough time to do that. So this one's just a little tricky because I have multiple triangles. So triangle SVR, I'm going to highlight it so you see what triangle I'm even talking about, congruent to UVT. So these are the triangles that I'm trying to get congruent to each other. And I know that SU and RT bisect each other. That means that they are both cutting each other in half. So a bisector results in congruent segments because this is a line bisector. SU and RT bisect each other, so they are both cutting each other in half. So SV is cutting RT in half. RT is being cut in half. Boom, boom, there are my 2 halves. And then SU is being cut in half. SU is being cut in half, so this half and this half are congruent to each other. So I'm going to write both of those statements down. RV is congruent to VT. And SV is congruent to VU. Now, how do I know those segments are congruent to each other? Because a bisector divides a segment into two congruent segments, just like a midpoint does. So I'm just writing definition bisector. And that's a C right there. All right, now I only have two sides, which is not one of my ways to prove triangles congruent. I need something else. There's nothing else in the given because I already used up the given. This is when you look to see if they share a side or they're vertical angles. Now those two triangles that I have highlighted in yellow don't share a side, but they do in fact have vertical angles. So I'm going to call those angles angle 1 and angle 2. And as we know, vertical angles are congruent to each other. So angle 1 is congruent to angle 2. Vertical angles are congruent. And you can always use abbreviations like for angles and for congruent. Now I have enough to say that the triangles are congruent. So triangle SVR is congruent to triangle UVT. Look at your picture, what you've marked. You have two sides and the angle between them. So you have side, angle, side. Okay, and again, how do I know whether I'm reflecting this or whether I'm rotating it? Look at the order of the letters. See how S matches up with the U. That means that this is going here. If I was reflecting it, S would have matched up with the T, and it doesn't. S matches up with the U, V matches up with V, and R maps onto T. So again, I am rotating this 180 degrees about point V. Okay? And we're going to try 5 in class tomorrow. 5 is not a hard one.